let's discuss about Kirchhoff's laws. There are two basic laws, Kirchhoff's current law and Kirchhoff's voltage law. First, we will discuss about Kirchhoff's current law. The algebraic sum of currents meeting at a node in a network is 0. So, in this circuit, I1, I2, I4 and I7 are incoming currents, I3, I5 and I6 are outgoing currents, and the sum of currents entering a node will be equal to 0. So, I1 plus I2 plus I4 plus I7 minus I3 minus I5 minus I6 will be equal to 0. Next law is Kirchhoff's voltage law. It states that at any instant of time, the sum of voltages in a closed circuit is 0. So, here in this circuit, the E is EMF in the circuit, R1, R2, R3 are 3 resistances and V1, V2 and V3 are 3 potentials across the resistors. So, E is equal to V1 plus V2 plus V3, or we can rewrite the equation as V1 plus V2 plus V3 minus E equal to 0. So, if current I is passing through the circuit, then voltage drop across the resistor R1 will be equal to IR1, voltage drop across resistor R2 will be IR2, and voltage drop across resistance R3 will be IR3. Then the equation E will be equal to IR1 plus IR2 plus IR3. Same thing I am explaining using one more example based on Kirchhoff's voltage law. So here you can see there are two batteries E1 and E2 and there are 4 resistances R1, R2, R3 and R4 with branch currents I1, I2, I3 and I4. So now if we apply Kirchhoff's voltage law, then we can see if the current is passing from positive terminal to negative terminal of the resistor, we will consider it as a voltage drop and then the voltage drop will be written as minus I1 into R1. And if the current passes from negative terminal to the positive terminal of the battery, we will be considering it as a positive EMF. So now if we just assume those two conditions, minus I1 into R1 plus E1 minus I2 into R2 minus I3 into R3 minus I4 into R4 plus E2 will be equal to 0. Again if we rewrite the equation, so E1 plus E2 will be equal to I1 R1 plus I2 R2 plus I3 R3 plus I4 R4. So here the total EMFs in the circuit will be equal to the sum of voltage drops around the closed loop in this circuit. Now, applying Kirchhoff's laws, we will write relative equations of various branch currents and we will solve the values of I1 and I2. So, initially from this circuit, we will be writing the equation for A, B, E, F loop. So, here we can see by applying KVL, loop 1 that is A, B, E, F, A, it is 50 minus 15 I1 minus 20 I2 which is equal to 0. Similarly, for loop 2 BCDEB minus 30 into I1 minus I2 minus 100 plus 20 I2 equal to 0. So, if we just name the equations as 1 and 2 and if we solve them, we will get the currents I1 and I2 and also the current I1 minus I2. So, I have just given the lecture notes on two laws, Kirchhoff's current law and also Kirchhoff's voltage law. Kirchhoff's current law states that the algebraic sum of the currents meeting at a node in a network is 0, or the sum of currents entering into any point is equal to sum of currents leaving that point. Kirchhoff's voltage law states that at any instant of time, the sum of voltages in a closed circuit is 0, or in any closed circuit, the algebraic sum of voltage drops around the loop will be equal to the total EMF in that loop. Thank you.